In this class we are going to discuss about the next concept, that is flip-flops. Okay, so this is related to the sequential circuits. Okay, so and in that lecture we will discuss about what is meant by flip-flop and what are the classifications of flip-flops and what is the working principle of flip-flop. All those things we have to discuss here. Okay, so before going to start the flip-flop concept, first we should remind one thing, that is nothing but what is meant by sequential circuit. So sequential circuit is nothing but whose output is depends on present input as well as past output. So that circuit we can call it as a sequential circuit. So the best example for sequential circuit is flip-flops. Okay, so now we'll see the flip-flop concept here. So first of all, in that you need to know the basic definition about flip-flop. Okay, so first, flip-flop is a binary store. Okay, so our binary state we are calling. So what is meant by flip-flop? So flip-flop is nothing but a binary state, so which is capable of storing one bit of information, that too either it can be 0 or it can be 1. Okay, so what is meant by flip-flop? So flip-flop is a binary stage or binary state. Okay, so which is capable of storing the one bit of information, so that information either can be 0 or either can be 1. Okay, so here in simple terms we can say that the flip-flop is a sequential circuit, so which has two states, so that and can be used to store state information. So which has two states is nothing but here it either can be 0 or 1 state. So we just now we said that is nothing but it can store the binary information. So it has two states, that two binary information as 0 or 1, and can be used to store the state information also. Okay, so it can be storing capability also there. Okay, so whatever the information we have, that will be stored in this flip-flop register. Okay, so now it will have the two states, no, that to either 0 or 1. So that is nothing but completely we are having the binary information here. Okay, so this is the block diagram of flip-flop. So this flip-flop consists of the inputs and outputs. So the inputs will be considered as n number of inputs we should consider, and the flip-flops outputs we are consider as only two outputs. One is Q and Q complement. Here what is meant by Q means Q can be considered as normal output, and Q complement we can consider as, that is complement, that means inverted output. So exactly normal of opposite. If the normal output is maybe 1, for example, if normal output may be considered as 0, so then what about the complement output means we can consider as 1. So that means exactly opposite to that normal output, that is the complement output. Okay, so this is the flip-flop block diagram. Now let's see the classifications of flip-flops. So these flip-flops are classified into 4 types. One is SR flip-flop, D flip-flop, JK flip-flop and T flip-flop. Okay, so here the first type is SR flip-flop. So for this, what is meant by S and R is nothing but set and reset flip-flop. Okay, S is nothing but set and R is nothing but reset flip-flop. Okay, so D flip-flop is nothing but we can call it as like a data or delay or data flip-flop. Okay, so what is meant by JK is nothing but we are calling like a John Kilby flip-flop, and T flip-flop is nothing but that is toggle flip-flop. Okay, so and in that JK flip-flop is also can be drawn using master slave JK flip-flop, that we will do it later. Okay, so in that another type is also we are having, that is master slave JK. So master slave JK is nothing but, so that will be drawn from the JK flip-flop only. It will if you know this JK flip-flop explanation, so then master slave JK flip-flop is very easy. Okay, so now we will see that we will do it later for master slave JK. So now we'll go with that first one in that is SR flip-flop. So in that, what is meant by S and R is nothing but set and reset. Okay, So just now I explained flip-flop can be stored as two states, no, that too either 0 or 1. So here in set and reset flip-flop, in binary terms we can say that the set can be represented as 1 and the reset can be represented as 0. Remember that one. In binary states we can say that set and reset pins as 1 and 0. Okay. So this set and reset flip-flop is implemented by using SR latch using NAND gates. Okay. So this SR flip-flop can be constructed with the help of SR latch using NAND gates. Whatever the circuit diagram we are having in SR flip-flop, that will be designed by using SR latch circuit with the help of NAND gates. And also it consists of one additional clock input. Okay. So here we will have NAND gates and we will have additional enable inputs clock signal. Okay. So let's see the block diagram of SR flip-flop. So this is the block diagram of the SR flip-flop. So here S is the one of the input and R is the one of the input of SR flip-flop, and this is clock, we are calling like a enable input, this one. Okay. So CLK is nothing but that is the clock signal. And here what about Q and Q complement is normal output and complement output. Already I explained in the block diagram of flip-flop. Okay. So this is the block diagram of the SR flip-flop. It just consists of the 3 inputs and 2 outputs. Okay. So in that one input we can consider as the enable input. So if the clock signal is enabled, then only the circuit will be run. Okay. That means if the clock is activate position, so then only the circuit will be activate. If the clock is in disabled position, then the circuit will be in disabled. Okay. So remember that logic. So now we will see the circuit explanation for this. So this is the circuit diagram for the SR flip-flop. So just now I explained, no, this SR flip-flop consists of the SR latch using NAND gates. So here what is the SR latch means? This is the SR latch we are having. Okay. This is called as the SR latch. Okay. So see here, this SR flip-flop consists of the first 2 NAND gates. So in that the first NAND gate of one of input is connected to the S input and the another input is connected to the clock signal, and like this way second of NAND gate will be connected as one of input is R and another input we should connected as clock signal. That means first 2 NAND gates of the another input is connected as the clock signal. Okay. So now coming to here. Here the 2 gates, whatever the 2 gates we are having, third and I will give the numbers here 1 and 2, and this is the third and 4. Okay. So whatever the third gate and fourth gate we are having, so in the third gate one of input is connected as output of first gate and the fourth gate of one of input is connected as second gate of output. So like this way third gate of one more input we should collected from the here. Okay. So the 2 gates outputs are connected to the one of input of these 2 gates and other input of these 2 NAND gates comes from here. So this input is comes from here and this another input is comes from here. Okay. So totally we have 2 outputs Q and Q complement. So now let's see the working principle of the SR flip-flop. So this is the circuit diagram. So now we'll see the working principle of the SR flip-flop, and that output will be implemented in terms of the truth table. Okay. So depends on working principle, we'll write the output in terms of the truth table. Okay. So what is meant by truth table means, before going to see this working principle, so first what is meant by truth table means, so truth table is nothing but the relation between inputs and outputs, will write it as truth table. Okay. So the relation between inputs and output, whatever the information we are having, so that information we are calling like a truth table. Okay. So truth table can express as the relation between inputs and outputs. That's why I can mention here only these inputs and output part. Okay. So now we'll see here the inputs are clock, S and R, and the output will be Q. So here I am considering the output will be next state output. So Q is our present state output, means next state what is that? So that is nothing but Q1. If you are having the output will be Qn, okay, Qn complement. So then what about the next state output? N of next state is nothing but n plus 1, right? So next here we can consider as the directly next state output we should consider. So what about the present state means? So we don't know the present state values because sequential circuit output will be depends on the present input as well as past output. So that past output we should consider here also. Okay, so see here how to get the output. So now we'll see the working principle. So if you know the working principle, then write the output in terms of truth table. That is very easy. Okay, so first thing is whenever the clock signal is low, okay, so that means whenever the clock signal is in disabled position, so then automatically the inputs S and R, it does not affect the output. Okay, it does not affect on the output because it remains the no change operation. That means it remains no change state. So whenever the clock signal is high, the following changes are occurred. So I will show that. So remember one thing, whenever the clock signal is low, that is nothing but 0. Low means 0. Okay, so whenever the clock signal is 0, so then the inputs does not affect on the outputs. So then we'll get the output is no change. Okay, so whenever the clock signal is high, that means 1, so compulsory the inputs are affected by the output states. Okay, so that means we are getting the following outputs if the clock input is 1. So what happened? So first, whenever the clock signal is 0, what is the output we are getting? No change. So that is means inputs does not affect on the output state. So you should mention as inputs and outputs will be all in disabled position. So you can mention as the 0 0 inputs, and here output you should write in terms as no change. Okay, so now whenever the clock is activated, okay, so 0 0 position, no change operation we are getting. So whenever the clock is activated, so it is in high position, so then the inputs, if both the inputs S and R will be 0 0, okay, so see here ma, we'll have the two, except clock signal we have the two inputs. So for sequential circuit or combinational circuit or whatever the logic gate you are having, if any gate having the two inputs, then how many possibilities we are getting? So from Boolean algebra you can consider that one. So if you are having two inputs, then the binary combinations we are getting like a 4 possibilities. That 4 possibilities are 0 0, 0 1, 1 0, 1 1. So that means here we are getting the possibilities are 0 0, 0 1, 1 0, 1 1. Here also each gate consists of the two inputs, no, that's why we are getting the, so that means SR flip-flop having the two inputs, then we are getting the 4 possibilities 0 0, 0 1, 1 0, 1 1. So in that way always the clock will be in active position. So that means why we are considered for all these 4 cases of clock will be enabled means whenever the clock is activated, inputs are connected. Whenever the clock is disabled, the inputs does not affected. Okay, so here the clock is activated means inputs are activated. Okay, so then the circuit is in on position. So now we'll see the output. What is that? So whenever the clock is high, both the inputs are zeros. That means if the both inputs of SR flip-flop are 0, so then the flip-flop enters into the hold mode. Hold mode is nothing but it does not react on the inputs. So again we have to get the output is no change because the present state output will be equal to the next state output. Okay, so see here whenever the circuit input is 1, that means clock input is 1, so it is enabled. So then automatically the clock will be activated. So that means the output result is no change because there is no change in our previous state. So previous state of Qn plus 1 is, what is that previous state? Qn. So Qn of next state is Qn plus 1. So next state Qn means previous state is Qn plus, next state is Qn plus 1 means previous state is Qn, right. So automatically we can say that there is no change in our previous state. Suppose if previous state is Qn, then the next state is does not affect on the output. So then we may get it output as no change output. So now coming to the second case. So if the clock is enabled, that means clock is high, so then the inputs S will be 0 and the R will be 1. So then the flip-flop enters into the reset mode. Okay, the flip-flop enters into the reset mode. So in the reset mode, the data inputs reset the output Qn plus 1. So that means the output we will get it as in binary. So reset output we will get it as in binary means what? 0. So that means Qn plus 1 value we are getting in reset position is 0. Qn plus 1 complement, what is the result? Qn plus 1 is 0. That is reset position. What about the complement value? So exactly opposite to this one. So that is nothing but 1 we are getting. So now coming to the third case. Whenever the clock is enabled, S input is 1 and R input is 0. So what is the result we are getting for this means automatically this SR flip-flop enters into the set mode. Then the output in binary is 1. So that means Qn plus 1 value will be entered into the 1. Qn plus 1 complement value will be entered into the 0. Okay. So then the outputs are 1 and zeros. Okay. So now coming to the last case, whenever the clock input is high, then S input is 1 and R input is 1. So both the inputs are 1 1. So then automatically the flip-flop outputs are entered into the same case. That is nothing but it will be having the outputs as Qn plus 1 will be 1 and Qn plus 1 complement will be also 1. So that is nothing but these two are not corrected. If you are having normal output is 1, so compulsory complement output will be opposite of that one, right. So but here the condition is not satisfied. So in both the inputs are in 1, so automatically the flip-flops enters into the 1 output. So then automatically we can say that this condition is not satisfied for normal output and complement output. So then we can say that this case is invalid case. Okay. So these are the output operation for SR flip-flop. So totally we have the 4 states. Whenever the clock is enabled, S and R will be 0 0, then we'll get it as no change operation. So and S and R will be 0 1 input for we are getting the reset output, and for 1 0 set output, and for 1 1 invalid case we are getting. Okay. So this is the result we are getting from the SR flip-flop. Okay. So for whenever clock is high, we are getting the 4 possibilities. Okay. So you should learn about the truth table of this SR flip-flop. You have to by heart this concept which is very very important, whatever the flip-flop we are having in that. So that is very very important concept we are having in that. Okay. So compulsory the further concepts will be depends on this all flip-flop circuits. Okay, remember that one. So this is the complete explanation about the SR flip-flop. You should remember the truth table. So if you know this truth table, you can try to find out the logical also. That is nothing but like this. If you want to substitute S and R values in NAND gate, so what is the S value? 0. R value is 0, right? So S is 0, R is 0. I will how to get the no change operation now I will show here in mathematical. So see here 0 0 I can substitute, and what is the clock signal input? 1. So here 1 and here 1. So you know the NAND gate output, no? So what is the NAND gate output? So NAND gate output is nothing but A into B complement, right? So now I will take it as case 1. So that is clock 1, and S will be 0, R will be 0. What is the result we are getting? Now see here. how to get the no change operation. So first gate 1 I can find it G1. So that is nothing but 0 into 1 complement. NAND gate, no? So substitute A and B values here. A and B is nothing but S and clock. 0 into 1 complement. 0 into anything 0. 0 complement is 1. Like that. What is the G2 gate result? 0 into 1. And again whole complement. So 0 complement is 1. So now we know the G1 and G2 results 1 1. So that will be given as inputs of the third and fourth gates, right? So what about the another inputs for these two gates means you should take it from here. Okay, so this input you should take it as this is the next state input, right? So I can consider as past output for this. Just imagination purpose I can consider. So this is the past output of for this. So Qn complement. So previous state is nothing but what is that? Nth stage. N plus 1 of previous nth stage. So that you can consider here this is Qn and this is Qn complement. So now find it the G3 output. So G3 outputs is nothing but inputs are 1 and Qn complement. 1 into Qn complement whole complement. So then we will get it as Qn complement whole complement. So that is Qn. So A bar whole bar is nothing but A, no? Like that. So now find it the G4 1 into Qn. So 1 into Qn whole complement. So Qn complement we are getting. See here G3 result and G4 result now we are getting. So G3 result is equal to what? Qn plus 1. So this result is equal to the Qn plus 1 and this result is equal to the Qn plus 1 complement. Now see here. So normal value is nothing but normal value only we are getting. N plus 1 state is normal value and nth state is also we are getting the normal value. We didn't get any complement for this normal state. Like this in complement case, complement only we are getting. So that means present state is does not affect on the future state. Both will be equal here. So past state and present state both will be equal here. That's why the inputs does not affect on the outputs. So you can mention as no change. So like this we are getting the output here. Okay, so try to find out all these conditions of outputs also. You can substitute these inputs in this formula. Okay, you can follow this procedure, then you may get these results. Okay, so this is the complete explanation about the SR flip-flop. So like this you can find the remaining cases also. 0 1 case, 1 0 case, 1 1 case if you need that explanation. Okay.